Let's look at an improper integral. See how to do that. Okay, so we got the integral of it's getting way too late for me. Natural log of x squared dx. I remember I meant for this one to be easy, and it came out hideous, but that's okay. Limit as b goes to infinity, and then 1 to b, and then natural log of x, 1 over x squared dx. Now there's no real easy way. If I set this equal to u, du would be 1 over x, but I got 1 over x squared, so that doesn't fit. Maybe it isn't so bad to have this way. Well, I can rewrite this as 1 over x squared, natural log of x dx. And I can rewrite it as 1 over b, natural log of x times x to the negative 2 dx. And I'm going to use integration by parts. This is going to be u, this will be dv. So, if u is equal to natural log of x, dv is equal to x to the negative 2 dx, du, derivative of this, gives us 1 over x dx, and v would be the integral of x to the negative 2 dx. Well, we add 1 to our power, divide by our new power. So v is going to equal to negative 1 over x. Okay, our formula. I'm pretty sure all we need is past 1, but our formula is uv minus integral of v du. So limit as b goes to infinity of uv. What was u? U was natural log of x times v, which was negative 1 over x, and then minus the integral of v, which is negative 1 over x, du, and du was 1 over x dx. I'm going to put the 1 and b back on this here in just a second. Make it a little sloppy, but let's see, 1 over x. I'm just double checking everything. Okay. So then that gives us the limit as b goes to infinity of negative natural log of x over x, and I can bring that negative out, so it becomes a positive. And 1 over x times 1 over x is 1 over x squared, or x to the negative 2 dx. So this becomes limit as b goes to infinity of negative natural log of x over x. Add 1 to your power, divide by new power, and then I'll apply that for both of those. Okay, so this becomes limit as b goes to infinity, and I could actually merge these together because this goes down below, and we have negative 1 over x in this. So we've got negative natural log of x minus 1 over x, like that. The negative I could put completely out in front. And then this becomes natural log of x plus 1 over x. And let's plug these in now. So plug into b, so I got natural log of b plus 1 over b minus natural log of 1 plus 1 over 1. And let's see, that gives us negative limit as b goes to infinity of natural log of b plus 1 over b minus natural log of 1 is 0, so that drops away. 1 minus 1 is 1. Okay, now if I plug infinity in here, I'll have infinity over infinity. So I can use L'Hopital's rule to simplify this. Now this negative one is trivial, so I don't need to worry about it. I could actually split these into two separate integrals if I wanted to. Integrals, two separate limits. And 1 o'clock's too late for Calc 2. Let's take derivative of the top. Well, derivative of natural log of b is 1 over b, and the 1 disappears. And down below, the derivative of b is 1. Okay. So then this just becomes 1 over b minus 1. And now I can plug in the infinity, and we'd have 1 over infinity minus 1. 1 over infinity is 0. And 0 drops away, and we end up with a positive 1 for our answer. It wasn't too bad.